Next is rotation of Earth. It also affects the value of the acceleration due to gravity. Suppose this is the Earth which is rotating about its axis. This is the axis of Earth. It is center of Earth, and there is a mass m on the Earth's surface which makes angle theta with the axis of rotation. This mass makes the circular motion about this axis as the Earth rotates about its axis with angular velocity omega. These forces are, one of the forces, gravitational force. This is the gravitational force G, mass of Earth, mass of body, and distance between them is r square. Or we can say this is the weight of the body, mg, if there is no other forces acting on it. Other than this, there is one of the more force. Because Earth is a non-inertial frame of reference, meaning it is an accelerated frame of reference. On accelerated frame of reference, Newton's law of motions are not applicable. If we want to apply the Newton's law of motions, then pseudo force to be included. And here, this mass is moving on this circle. And because angular velocity is omega, so there will be a centripetal force that is equal to m omega square into radius of the circle in which this mass m is circulating, and it will be equal to m omega square, and this is the r. This is the radius of the circle in which this mass particle m is circulating, and it will be equal to, using the trigonometry we can find, this is the radius of Earth, cm. Cm is the radius of Earth, so small r is the r sine theta. So we can write it is r sine theta. This is the centripetal force. So to apply the Newton's law of motion on this non-inertial frame of reference, this centripetal force is acting towards the center of the circle. So a centrifugal force or a pseudo force will act outward, and this has the magnitude m omega square r sine theta equal to the centripetal force. So it means the mass body has two forces acting on it. One is the Newton's force of gravitation that is acting towards the center, and another is m omega square r sine theta. This is a pseudo force which is acting outward opposite to the centripetal force. We take the two cases. In general, net force will be the total sum of vector sum of these two. We take two special points, that is, one is taken on the equator. This line through the middle of the and passing through the center is called the equator. At equator, the forces are acting in opposite direction. M omega square r sine theta is acting outward, while the gravitational force mg is acting towards the center of the Earth. So net force will be mg dash. This is the net weight or net gravitational force of attraction. It will be equal to mg minus m omega square r sine theta. And from this formula, this theta is for equator 90 degree. If we take this line to the equator, this theta will become 90 degree and sine 90 will become 1. That means mg dash will become mg minus m omega square r, and m will be cancelled out. That means g will be equal to g minus omega square r. This is the resultant or effective gravitational acceleration or gravitational field, at the equator. Another point of interest is at pole. At pole, it is a pole. Top point is the pole, or the lowest point is the pole. These are poles. The mass body at the pole will have the forces. One of the force of attraction, that is the gravitational force. It is the mg acting downward, and another will be also m omega square r sine theta. And for points on the poles, this theta will be 0. If theta is 0, then this pseudo force will be 0. That means at poles, gravitational acceleration will be equal to g. Shape of the earth also have the influence on the acceleration due to gravity. Actually, earth is not a spherical, it is elliptical. It means it is larger at equator, radius is larger at equator than the poles. This is a major axis, and this horizontal axis is major axis, and vertical axis is the minor axis, and this major axis is larger than the minor axis. That means if mass is on the equator, then it is at larger distance than the from the center than the poles. This is equator, this is pole, this is the center. So we can say this is r equator and this is the r pole. So we can say r equator is larger than the r pole, and acceleration due to gravity at the surface is, we have written gm oblique r square. So from this formula we can say if r equator is greater than r pole, then g equator will be less than g pole. It means acceleration due to gravity will be more at pole because distance of the mass from the center is less, while the gravitational acceleration will be less at the equator because of the larger radius. Let's do some problem. First problem is, draw the variation of acceleration due to gravity with distance d from the center of earth. This is the earth and it is the center. This is the radius r and it goes to up to infinity. We have to draw the graph of acceleration due to gravity with distance d. This distance is from the center. Earth can be treated as the solid mass sphere. We will discuss this in detail in the gravitational field topic. Here we have to remember that E d, d is the distance from the center. It will be equal to gm oblique r cube into d if d is less than r. That means if the point is inside the earth, then gravitational field or gravitational acceleration, we will say it is gm by r cube into d. And if it is greater than r, then this will be equal to gm oblique d square. And at the surface of earth, we can write it is gm oblique r square if d equal to capital R. This information we have to remember. We will derive this relation in the gravitational field topic. From this relation we can draw, or we can find the information that for d less than r, this term is a constant term, only variable term is d, and ed is proportional to d. Here in first case, ed is proportional to d. It is similar to y equal to mx relation. So line, it is a straight line which passes through the origin and has a slope m. So we can draw this line in this way. This is the graph for the region when d is less than r. It is a straight line inclined graph where slope is gm oblique r cube. After that, when we reach at d equal to capital R, this value is gm oblique r square. That means here this value refers gm oblique r square. After this, the relation is gm oblique d square. If d is greater than r square, here it says ed is inversely proportional to 1 by d square. So the graph will be a curved graph and it will be in this form. So graph will be this. This is the graph of acceleration due to gravity for the case of Earth when distances are measuring from the center of the Earth. O is the center of the Earth. Second question. Find the height at which the acceleration due to gravity becomes g by 9. Acceleration due to gravity at the surface of Earth is gm oblique r square, and at other point we can write it is gm oblique r plus h whole square. At the surface, it is the gravitational field at the height h from the surface. So we have to find the height at which the acceleration due to gravity becomes g by 9. So it is g by 9. On comparing, we will have, we divide this equation number 1 by equation number 2. So we will get g by 9 equal to gm oblique r square by gm oblique r plus h whole square. It is equal to g and g will be cancelled. So 9 will be equal to this gm and gm will be cancelled. It will be 1 plus h by whole square by r square. And on taking the square roots on both sides, this 3 will be equal to r plus h by r, or 3r equal to h plus r, or h equal to 2r. So at the height 2r from the surface of Earth, acceleration due to gravity becomes g by 9. That is the 1/9 of the value of Earth's surface. Question number 3. The change in the value of g at the height h above the Earth's surface is same as the depth d below the Earth's surface. If h and d are very less than small r, find the relation between h and d. This we have already derived that g dash equal to g into 1 minus 2h by r for a point at height h from the Earth's surface, and h is very less than r. Similarly, g dash equal to g 1 minus d by r for d very less than r. It is above the Earth's surface and it is below the Earth's surface. As per question, change in the value of g. So change in value of g is g dash minus g, or we can say g minus g dash. This is the change in value of g, and its value is g minus g dash in the first case is g into 2h by r. It is equal to, in second case, it is equal to g into d by r, and these two values are equal. So by comparing this, g and g will be cancelled, r and r will be cancelled. We can say 2h equal to d. This is the relation between the h and d. Object is at height h from the Earth's surface and potential gravitational acceleration is g dash. Then the same gravitational acceleration we will get at a depth d, which is equal to 2h.